You know, every time you flip a light switch or use your phone, you're tapping into this vast, hidden world of high risk work. We're talking mining, heavy transport, aviation, places where the stakes are literally life and death. Today, we're going to pull back the curtain on the invisible, highly engineered systems that are designed to keep people in these dangerous jobs safe.
So, what does it really take? I mean, really, it's not just about common sense or putting up a sign that says be careful. It's a science. It's this meticulously designed architecture of rules, procedures, and engineering, all built on decades of experience, and honestly, often learned the hard way.
So here's how we're going to dive in. Think of it like peeling back the layers of an onion. We'll start with the big picture, the world of high-risk work. Then we'll look at the actual blueprint for safety. From there, we'll get into the specifics of controlling massive machinery and the insane checklists used in aviation. And finally, we'll get to the most important part, protecting the people at the very heart of it all.
Okay, so first things first, we're not talking about making sure your office chair is ergonomic. We're talking about environments with explosive potential, with massive moving equipment and extreme conditions, where just one tiny mistake can be catastrophic. In places like these, safety isn't just a priority. It has to be engineered right into the foundation of the work itself.
Now, what's so fascinating about all this is that whether you're dealing with a chemical storage tank or a helicopter landing in the mountains, the approach to managing the danger follows a kind of universal blueprint. It's this methodical, step-by-step process that you can apply to pretty much any hazard you can think of. And here's that blueprint. It's actually pretty logical. First, you identify every single thing that could possibly go wrong. Then, you assess the risks. How likely is it to happen, and how bad would it be if it did? Next, you implement controls to either get rid of that risk or at least minimize it. And finally, and this is key, you document everything in a permit system so that absolutely nothing is left to chance. Let's see how this works with a real example. Take a confined space. Sounds simple enough, right? But the official definition covers everything from a giant storage tank to a deep pit. And the hazards here are often invisible. We're talking poisonous gases, a lack of oxygen, or even the risk of being buried alive. This is where that safety blueprint we just talked about becomes absolutely critical. So before anyone can even think about going in, a permit like this has to be filled out. It's a forcing function. It makes the team stop, think, and plan. They have to name the people going in, list out all the hazards, test the air and record the results, map out the emergency plan, and get a formal signature. This isn't just a piece of paper. It's a life-saving force field built out of procedure.
All right, so we've seen how the blueprint works for invisible dangers. Now let's see how it applies to hazards you can definitely see and feel. We're moving into the world of heavy mobile equipment, where the massive scale of these machines is a hazard all by itself. And this right here shows you that safety is absolutely not a one-size-fits-all deal. A regular truck on the highway, it needs airbags and seatbelts for a crash. But a haul truck that never leaves a work site, it needs totally different things, like a reinforced cab to protect the driver from falling rocks, and an automatic fire suppression system. The safety features are tailored to the actual risks of the environment. But the engineering of safety goes so much deeper than just the machine itself. Let's zoom way in, and I mean way in, on a single component you might think is pretty simple, a tire. But on this scale, well, nothing is simple.
5 pounds per square inch. That's it. When a mechanic is working on one of these enormous split rim tires, it has to be deflated to practically zero before they can even touch the retaining rings. So why? Why is the rule so incredibly, ridiculously specific? Because the amount of stored energy in one of these giant tires at full pressure is just immense. If a component fails or isn't seated perfectly during inflation, the result isn't a little pop. It's a violent, lethal explosion. The only thing standing between that worker and total disaster is following the procedure, to the letter. And to manage that risk, this whole rigid set of controls is put into place. The tire has to be inflated inside a heavy-duty steel cage that's literally bolted to the ground. Every single component is watched like a hawk to make sure it's seating correctly. And you can't just top up a low tire. No way. It has to be completely removed and inspected first. It's basically a system designed to contain a bomb. Okay, from containing energy on the ground to defying gravity in the air. Now, we all know that commercial aviation is incredibly safe, but the standards for charter flights that operate in really remote, often hostile environments, they are on a whole other level of meticulous. I mean, just look at the sheer depth of experience we're talking about here. To captain a jet on one of these flights, a pilot needs at least 3,000 total flight hours. That's more than a third of a year spent in the air, and 100 of those hours have to be in that specific type of plane. This isn't just about having a license, it's about having deep, specific, hard-won expertise. And the rules extend to the machines too. These standards define what are called helicopter performance classes. A Class 1 helicopter, which is what you'd use in a hostile environment, has to have enough power to keep flying safely even if one engine cuts out. A Class 3 helicopter, not so much. In that case, an engine failure means you are landing right then, right there. The choices machine itself is a critical safety control. And then you have something like hot refueling, which is exactly what it sounds like, refueling a helicopter while the rotors are still spinning. It's incredibly dangerous, so there's a strict procedure. A pilot has to be at the controls, no passengers allowed on board, and you need at least 2 people on the ground, one to handle the fuel, the other to watch with a fire extinguisher. They even cap the fuel flow rate. It's this dangerous stance where every single step is choreographed for safety. So we've covered procedures, we've covered machines, but the final, and you could say the most important layer is about people. Because safety isn't just about protecting employees from a piece of equipment, it's also about protecting entire communities and upholding basic human rights. Now, this might be a side of industrial safety you've never even thought about. This commitment means the company holds all of its security operations, whether they're in-house or contracted out, to a global standard for human rights. It's a formal way of saying that how you provide security is just as important as the security itself. And these aren't just words on a page. These principles are put into practice through really rigorous vetting. Security staff have to have clean criminal records, complete specific training, and meet a minimum age. And what's really crucial is that they get annual refresher training on these human rights principles. This shows how the safety system extends beyond the fence line to make sure it protects, rather than harms, the community around it. So let's bring it all back together, from the invisible threat hiding in a confined space, all the way up to the global principles of human rights. We've seen that in these high-risk worlds, safety is anything but an accident. When you see all these rules, permits, and checklists, it's really easy to just dismiss it all as bureaucracy or red tape. But it's not. It's an invisible, life-saving shield. It's a system built from the hard-earned knowledge of what works, what doesn't, and what it takes to make sure that at the end of a very dangerous day, everyone gets to go home. It really makes you wonder, doesn't it? From the elevator you ride to the bridge you drive across, what other invisible systems of meticulously engineered safety are protecting you every single day, completely unnoticed? It's a hidden world of safety, and it's all around us.